This is section 12.3, and now we're going to look at the geometric sequence. And so for a geometric sequence, here's our formula that we need to know. A sub n is equal to a sub 1, which is your first term, times r to the n minus 1. So a geometric sequence occurs when the terms are different by exactly the same ratio. It's not being added, but you're dividing or multiplying by the r. So in this example, when you have 2, 6, 18, 54, 162, 6 divided by 2 is 3. 18 divided by 6 is 3. 54 divided by 18. So if you find that you're either multiplying by 1/3 to get to the next one or dividing by 3 if you went backwards, you are getting a ratio. So in this example, it says determine if the sequence is geometric. So 2 to the negative n. So let n equal 1, 2, 3. And you get 2 to the negative 1 is 1/2, 2 to the negative 2 is 1/4, etc. So you have 1/2, 1/4, 1/8. Those would be the terms in the sequence. And you can see if you multiply each term by 1/2, you get the next term. So yes, that is geometric. In this one, 1, 3, 6, 10, is there a common difference? Well, when you subtract, you get 2, you get 3, you get 4. So it is not arithmetic. Is there a common ratio? I multiply 3 by 2 to get to 6. I can't do that to get to 10. So there is no common ratio. So that's a neither. In this one, -1, -2, -4, -8. So let's see what the common, if there's a common ratio. -2 divided by -1 is 2. -4 divided by -2 is 2. And then -8 divided by -4 is positive 2. So the geometric ratio is 2. All right, now this formula is the one we looked at the very beginning, and it says find the 5th term and the nth term. So if the first term in this is 2 and r is 3, we're just going to plug those things in up here. So here's our formula again. A sub 5 equals 2, which is our a sub 1, times the r raised to this 5 minus 1 is 4. So then that's just a calculation. 3 to the 4th is 81 times 2 is 162. And then a sub n, you just take the r that you got in the first term and you write the formula and put n minus 1. That gives you a generic. The sum of a geometric sequence is this formula. The first term times 1 minus r to the n over 1 minus r. So that's just another formula that we'll see in a little bit. I'm putting that right there. Find the 7th term of this sequence. We have a sub 1 is 1, and we had to figure out the r. 1/2 divided by 1 and 1/4 divided by 1/2, they both give you 1/2. So a sub 7 is 1 times 1/2 to the 7 minus 1. That is 6. 1/2 to the 6th is 1 over 64, and we're multiplying by 1. So that's our answer. If we're doing summation of these, you can still use math and go up to summation. If you have the newer one, it will look like this. If you have an older calculator, you'll have to get the sum sequence and then put the function in x, lower limit, upper limit, and the same path that we use for the arithmetic one works here. So it's just on the calculator. You're hitting second stat, over to math, choose number 5 for sum. And then second stat, over to ops, choose 5, that gives you sequence. So you've got the first 2 items. Then you just put the function, the variable x, the lower limit and the upper limit, and that should get you that. We do have an annuity, amount of an annuity theorem, and if P is how much money you've, a deposit made at the end of each payment period for an annuity, the amount A after N deposits. So A equals P, that's the deposit, times 1 plus I raised to the N, and I is the percent, minus 1 over I. And I think we have a problem with that, but we will have that problem, that formula to work from. All right, let's go look at our problems. All right, number 1, in a blank sequence, the ratio of successive terms is a constant, and that would be geometric. That's what we're working with. Decide whether the following statement is true or false. For a geometric sequence with first term A1 and common ratio R, the sum of the first n terms is. And you could go back to the lecture notes and see that formula, and so that is true. Find the fifth term and the nth term. So we are using this formula. We have a sub 1 is -9, r is 2. So a sub 5 would be -9 times 2 to the 5 minus 1. That becomes a 4. 2 to the 4th is 16, and you multiply it by -9, you get -144. The nth term means you're just going to plug in the -9 and the 2, -9 here, 2 there, and leave the n minus 1. So this is generic. We just put those terms that you were given in there. All right, find the fifth and the nth term, same thing. A sub 1 is 7. We're finding a sub 5. It wants the fifth term. So a sub 1 is 7. R is -5. And this becomes a 4. So -5 to the 4th is 625. Multiply by 7, you get 4375. And again, just plugging in a sub 1 and R for the generic. In this one, we're finding a particular term, and they didn't give us the first term specified, and they didn't give us an R. So in this one, in number 5, we have 1, 1/4, and 1/16. So first of all, to find R, we're going to find the ratio of 1/4 divided by 1, which is 1/4. And it would be the same thing if we divided 1/16 by 1/4. So our common ratio, R, is 1/4. A sub 1 is 1. We're just going to plug those in for a sub 6. So 1 times 1/4 to the 6 minus 1 is 5. And you get 1 over 1024. Number 6, find the nth term given that a sub 4 is -27 and R is -3. So if here's our formula, and we plug in what we've got. We're going to start here because we know a sub 4 is -27, so we know this part. So -27 is equal to a, we do not know the first term, times the R, -3 to the 3rd. So -3 to the 3rd is -27. We'll divide -27 over there so that we get 1 is A. And so A sub n is going to be 1 times -3 to the n minus 1. We don't have to put the 1 in our final answer. All right, same kind of idea in number 7, a little bit different. So they give us here a sub 2 is 7, a sub 4 is 847. All right, so if a sub 4 over a sub 3, that should give us an R, right? Because that would be our ratio. And a sub 3 over a sub 2 should give us an R. So a sub 4 over a sub 2, so we're going from here to here, should be R squared because we went down 2 levels. Then we write down that R squared is equal to 847, which is A4 right here, divided by 7, which is A sub 2. So r squared is equal to these, and then I plugged in these numbers for a sub 4 and a sub 2. That gives me 121. So r squared is 121. Take the square root, and you get that r is 11. All right, and so we still don't know our first term, but we do have our r now. So I'm going to this a sub 2. 7 equals a times 11 to the 2 minus 1. So 7 is equal to 11a. Divide by the 11, and you have 7/11 equals a. That's going to allow me to write the nth term. I'm going to put my first term here, my r here, and it's equal, and then it's n minus 1. Now, we simplified it because 7/11 times 11, that can be 7 times 11. That 11th can go away. So we have 7 times 11 to the n minus 2. And it didn't get written up here, but n minus 2 should go there. All right, number 8. We're using a graphing utility. We've done that a few times. And you either can go math and look for summation. If it's the older calculator, here's the steps for that. And I did it where I had the icon, and we get 1.499. It said round to 3 decimals. So 1.499 would be our answer for that one. Number 9, determine whether this is arithmetic, geometric, or neither. So 9n squared. So if n is 1, 2, 3, let's do that. So we get 9 times 1, because that'd be 1 squared. 9 times 2 squared would be 9 times 4. 9 times 3 squared would be 9 times 9. So we have 9, 36, and 81. There's not a common difference. If I multiply to get here, that's 9 times 4, but 36 times 4 doesn't give me 81. So there's no common difference or ratio, and so that's not arithmetic or geometric. Number 10. This is a little bit complex here. Let's kind of go through this one. All right, so we're supposed to determine whether this is arithmetic, geometric, or neither. If it is arithmetic, find the common difference. If it's geometric, find the common ratio, and then find the sum of the first 50 terms. Okay, so if we take n to be 1, 2, 3, 9/10 to the n. So 9/10 to the first is 9/10. 9/10 squared is 81 over 100. 9/10 cubed is 729 over 100. So for r, if we take 8100 divided by 9/10, that's the same as 81 over 100 times 10 over 9. Let me make this bigger. Just a minute. I'll let that go down for now. And we get 9/10. If you did it with this, you would get the same thing if we divided that by that. So there is a common ratio, and it is 9/10. The sum of the first term. So here is the formula. A sub 1 times 1 minus r to the n over 1 minus r. Right, so we are going to fill in this formula. We've got a sub 1 is 9/10, that's our first, times 1 minus, and then we've got r to the nth, because we're doing s sub 50, and that's n goes there, and then over 1 minus 9/10. You do this all in the calculator. Let me pull that up, because I did put it in. Let me push it over here. So I started out and did the 1 minus 9 over 10 to the 50th, and I did it with those parentheses. I got that number. Then I divided that by 1 minus 9/10. I got that number. And then I multiplied it all by 9/10, and I have what should be the answer, 8.954. So that looks like a mess. You're just plugging in the 9/10 that you got for r, and the 9/10, which was a sub 1, and you're doing it in the calculator. So it looks messy, but it really works out fine. I would do it in pieces like I just did here, and that should work. Okay, we'll make that go away for now, and we'll make this bigger. All right, number 11. Suppose you've just been hired at an annual salary of $17,000 and you expect to receive annual increases of 5%. What will your salary be when you begin your 4th year? Enter the salary you expect to receive. So each year's starting salary is a term of a geometric sequence. The first term, a sub 1, is 17,000, and then it's going to increase 5% each year, so R is 1.05. Because the rate is 5%, that'd be 0.05, but the difference between each will be 1.05. So we'll plug in, we'll have 17,000 for A, R is 1.05 to the third, because we're doing A sub 4, and when you do that in the calculator, that's just a calculation, you get $19,679.63. So that salary went up to that in the 4th year. All right, number 12. This is that annuity formula that I had on the front of the notes page, but I put it right here again. Scott and Alice want to purchase a vacation home in 10 years, and they need $30,000 for down payment. How much should they put in savings each month if the per annum, so that's every year, if the rate of return is assumed to be 3% compounded monthly? All right, so let's think about what we've got. A is the 30,000. That's what you're trying to get to. I is 0.03. That's the 3% divided by 12. So that's each month it'll be 0.0025. N is the 10 years, but we've got to have it in months. So 10 times 12 is 120. So we have our A, an I, and a 120. And P is, let's see, let's do all of this. So I didn't write it on here, but the thing that you need to do is, before you start, solve this equation for P, meaning you would multiply by I over here, and then you would multiply by I, and then you would divide by 1 plus 0.01 plus I to the n, and then you would have the minus 1. Let's see. A equals, we should do that. So in this one, we've got 30,000 times 1 plus I to the n minus 1. So I have not, I can't go by that. I've got to do this. This is A times I, here's our I, divided by 1 plus I raised to the n, and our n was 120, and then we have a minus 1. So if we do all that in the calculator, and what I would do this part down here first. I would do 1 plus 0.0025 to the 120, subtract 1 from that, and then whatever that is, I would divide 0.0025 by that, and then multiply by 30,000. So do it in steps, and you should get something like this. This is saying this is how much money they need to put in at the beginning, and do that every month so that they save for their $30,000 down payment. So the key to that was rearranging this formula at the start. So you should be able to do that. I may write that on for future notes. So that should get you through 12.3.